Whoa, good morning. C3-5 today. Keep this in mind. Today's glue-in, not too much here. Just giving you 6 new derivative rules. So again, keep that in mind because the next 2 glue-ins after this, we definitely have some heavy lifting. Today, just 6 rules for you. I'm going to show you how we derive the derivative of sine of x by investigating the graph of sine. But for the rest of these, I'm just going to give you the rule. But first, it's obviously a beautiful day for math. I'm looking out the window, sun's coming up, and it's crazy windy out there. Woo! But I'm glad I'm in here doing math. So, derivative of sine. So first off, I'm going to investigate the graph of sine of x. So, by the way, you should definitely be able to immediately reproduce this graph of sine and cosine for that matter, just for your own knowledge. If you can't reproduce this snap, do that. So there's our axis. We're just going to graph one cycle of sine. Notice how I'm taking care. Oops, what the heck did I do? Taking care to, what the heck was I thinking? Concave down. So notice how this graph kind of curves like this. This is important to notice. Curves like this is concave up from pi to 2 pi. So notice how I'm doing that. Concave up, concave down. That's called scaffolding, teaching technique. You'll see that later. So, derivative of sine. So this is the graph of y equals sine. So we're going to look at this graph and try to figure out what the derivative could possibly be. So I'm going to create another little axis here. Going from 0 to 2 pi. So, one word that typifies or completely explains the derivative is slope. Derivative is slope. Derivative is slope. Slope is derivative. So, we're going to look at our original graph, y equals sine of x, and consider the slope all along this graph. And my tip for you is always look for where the slope is 0 first. That's kind of an easy way to launch into these problems. Look for where the slope, where the derivative is equal to 0. So if we look at the sine graph, at the top of the mountain here, the ant would be level, it would be horizontal there. So a horizontal tangent, a tangent there would be horizontal. Right there at pi over 2, the slope is 0. And then if we look down here, at the bottom of the graph, in the valley, the slope is 0 there also. It flattens out before going back up again. So the slope is 0 at 3 pi over 2. So that's where the slope is 0. So now let's look on either side of those points. So let's look at on either side where the slope is 0. So from the left, the ant would be walking uphill. The ant would be walking uphill. So that means the slope is positive. So before pi over 2, the y value, the slope of the original graph, would be positive. So the y value here is the slope, the numerical value of the slope over here. So positive slope, positive y value. After pi over 2, the ant would be walking downhill, so the slope is negative. So the y value is negative. So we kind of start, recreating our graph here. So let's look at where the slope was 0 here at 3 pi over 2. From the left, slope is negative, so the y value is negative on the derivative graph. This is the derivative graph. So before 3 pi over 2, slope is negative. After 3 pi over 2, slope is positive. So, okay, this starts to look familiar. Wow, that looks terrible. So scale's definitely off there, but hopefully we recognize this as the graph of cosine. So, of course, this is calculus. Beauty is not subjective. Of course, the derivative of sine is cosine. Of course. And then, again, I'm just going to give you the rest of these. The derivative of cosine is negative sine of x. And then the derivative of tangent is secant squared x, which, don't forget, that means we really have a parentheses being squared because it's secant squared, and secant is 1 over cosine. So if you had to use a calculator to calculate what is the secant squared of, I don't know, pi over 2, you would use a calculator to type it in like that. And then derivative of cotangent is negative cosecant squared. And just considering how you would possibly type in this into the calculator if you needed to, it's negative and then parentheses squared. And cosecant is 1 over sine of x. So looking good, okay. Derivative of secant is sec x tan x. I don't know, for some reason that's my favorite. I don't know. So secant is 1 over cosine. And tangent is sine of x over cosine of x. I don't know. And then cosecant, the derivative of cosecant, is negative cosecant x, cotangent x. Sneak that in there. So there are the rules. And then again, if you need to remember what this is, that's 1 over sine x. And then cotangent is like tangent but flipped. So cosine of x, sine of x. I'll provide you a memorization document where it kind of combines all of these derivative rules here on C3-5 and the ones prior. So you should expect that, and I'll also post it on the website. And yeah, enjoy. You should be ready for this. Again, you should be memorizing these. That's as much as I can tell you. You should be memorizing all of these and making these flow naturally. And arguably, there's kind of a connection here. So derivative of sine, that's easy. I don't know. These two kind of go together. And then notice how the rest of them kind of come in pairs. So secant squared, negative cosecant squared. So there's some sort of relationship there. And then similarly with secant and cosecant, these kind of go together. So I would suggest memorizing these in pairs. Boom, boom, boom. All right, enjoy.